So, there are two kinds of kinetic energy. One is momentum, which is concerned with speed. The other is inertia, which is concerned with mass or weight. When you fire a gun, that is mainly utilizing momentum, because you're accelerating the bullet. You want it to have the most speed, so much so that the bullet becomes deadly, or at least becomes to the point where you can do things that a bullet would not normally do if you just tossed it at someone. And that's true to the bullet too. You know, the bullet may be going through something because it's going really fast, but that bullet is also going to be disintegrating. If it's going through a person, it's less likely to disintegrate, although if it's made of lead, it probably will. But if you were to shoot a bullet, even a nickel bullet, at, a concrete wall, it would probably become flat or come apart. Just like if you were to take a piece of styrofoam, there would be a speed at which you could throw that piece of styrofoam, or a grain of sand, better yet, because it'd be hard to throw styrofoam with any speed because it's not very aerodynamic. But there would be a speed at which you could throw a very light and maybe soft object through a brick wall, and it would disintegrate even more than a hard object like a bullet would. But that's what a gun does, basically. The gun utilizes a hard object that already has some inertia by being heavy, since it's made of metal, and it fires that at such a speed that it becomes deadly. And a cannon is a better example of these two things put together, because a cannonball could probably break right through a piece of concrete that a gun couldn't, because there's more inertia behind its projectile. But at the same time, it's probably not moving as fast. Well, it's certainly not moving as fast, because cannons are like old guns. But then there's things like a train. Say you have a train that's moving at 5 miles an hour. It would have to be moving, it would have to have some momentum, otherwise there would be no inertia, it would just be potential. So if you have a very slow-moving heavy object like a train, it could crash through that concrete wall pretty easily. But for a totally different reason than the piece of sand that we were talking about earlier. And when you think about this, it's interesting because these two things are put together when, say, you punch. When you punch and you do it properly, you're not putting your weight into your punch. You are holding your weight in a fixed position, like you're taking a stance, like you might be picking up or pushing or pulling something. You're taking a stance where you're going to get the most leverage. And then you use basically momentum. The only momentum here is your fist accelerating from your chest. Your body shouldn't be moving at all. That way you can combine the right amount of inertia, or the right inertia, you can have inertia behind the momentum of your fist and make an effective punch. Whereas if you're running into someone, the punch might have a lot of speed, but it won't be able to, with the kind of punch that's the proper punch, you can punch and retract very easily. Whereas if you're going like that, you're leaning into your punch. You have to pull your whole body back to punch again. And so that's just another reason why it's more practical. But the kind of punch where you're fixed is using your weight. It's combining your inertia with momentum from your punch. And this also comes into play when we're talking about cars. Cars are designed to be able to take forces on their outsides that are both from momentum and inertia, because the car is heavy. Some of them weigh, they weigh between like a half ton to several tons, depending on the car, unless you're talking about a truck, and they can weigh even more. But it also is moving very quickly, at least for our speeds. If you have a car moving 60 miles an hour and it crashes, there's going to be probably several feet of metal that will just completely crumple inward, and it's because the car is designed to do that. If it didn't, then either the metal would buckle or it would just keep fixed as the person inside slams against it and is basically obliterated. That's why when there's a train wreck, the train, it doesn't have crumple zones. The people inside are going to get injured with a much higher chance, at least, than with a car. Now, if you're going 120 in a car, you shouldn't expect the crumple zones in the car to be able to take out enough of your momentum and inertia for the forces to not have an effect on your body. I mean, at that point, the physical attributes of your organs change just like the physical attributes of a bullet might change when fired into something, because it's moving at a speed that it's not designed to, or at least it changes its attributes when it's moving at such speeds. So yeah, that's enough talk about kinetic energy.